I am Jaitila HACP, and this is the live demonstration of Kafka system created by me for the assignment. This is the system architecture. In here we have the zookeeper, Kafka broker, and schema registry as Docker images. When we run those images as containers, then uh, the Kafka broker then processes the orders in this way. The producer generates the orders and it serializes with Avro serialization. Then it sent to Kafka. That sent order is consumed by this consumer. It deserializes the order and then calculate the average price of this order. It is also set to retry on failure. There will be 3 retries, and if all the retries fail, then it will go to DLQ. What Avro serialization does to the data is that it compacts the data into a binary format, which reduces the size of data and it optimizes the transfer speeds compared to the more verbose formats like JSON or XML. The schema registry here stores and manages schemes for Kafka messages, which acts as a single source of truth for the data structures. The zookeeper can be told as a distributed coordination service that handles the cluster management tasks such as tracking the broker status, storing configuration information, and also managing leader election for partitions in the Kafka system. So this is the data flow. When the producer produces the message, it Avro serializes the message. Then using the schemas in schema registry, it creates the Kafka topics. In the message consumption, the Kafka topic is consumed by the consumer and Avro deserialization is done, then processed and the aggregation is updated. When the consumption fails, it will retry 3 times. If it is having a permanent failure after 3 times, it will send to DLQ. Next, I will demonstrate the Docker file, Docker container part. This is the Docker compose file. In here we have the zookeeper, Kafka, schema registry, and Kafka UI. When we up these containers, then we have the Kafka UI also. This is the Kafka UI. Here we can see what are the topics the brokers, consumers in the Kafka is running. So first, we can start the producer. As you can see, it is producing the orders one by one. 5 orders for the uh, topic, and then it will wait for 5 seconds and create the next batch. Then we can start the consumer. The consumer then consumes those orders created, and here I have added a simulated temporary failure to show the retrying attempt. Here it will retry the processing. And then we can look at the DLQ using the monitor topic created. orders DLQ. Here, as you can see, the topic is not even available because there's nothing sent to the DLQ still. So if you see in this UI, you can see the number of messages are getting increased. Here the number of messages are getting increased. Uh, so to demonstrate the sending of messages to DLQ, I stop the normal consumer and I have created a consumer to fail all the messages. When we run this consumer, all the messages will fail and those failed messages will go to the DLQ. This will intentionally fail all the messages. Then if we see the DLQ, you can see the messages are getting shown here. In here also you can see another topic was created, orders DLQ, and it is currently having these messages. So that's the live demonstration of working of this Kafka system. So what we have special in this Kafka is the having of asynchronous processing. So the producer doesn't wait for the consumer to consume the messages. And also using Kafka, we can have decoupling because services don't directly depend on each other. They only talk through the Kafka. In this architecture, we can scale our system. Multiple consumers can process messages in parallel. Uh, when we talk about the reliability, messages are even persisted, even the consumers are temporarily down because Kafka saves these messages in its database. So that's the conclusion of the live demonstration of this Kafka system.